Okay, let's flip our part upside down and tackle Operation 2. The first thing that I want to think about are these parallels here that we've been resting material upon. I want to make use of their parallel nature for the first time. And by that, I mean that one edge sits on the bottom of the vise and the other edge holds up the bottom of our material, and those two edges are parallel. If I slide them to the right a little bit so that they're hanging out of the vise, watch how we can use their existence to probe the bottom of our material. Imagine that I probe the top of the parallel where it's hanging out on the right. Because that line runs parallel all the way under my part, I've indirectly probed the bottom of my part, just like I told Fusion I was going to do. So let's do it. Close the vise, seat the part, add torque, and then bring your probe down until it is hovering above one of the parallels. It doesn't matter which one, but for some reason I always use the back. Probe it as your Z coordinate for your personal work coordinate system, and you're ready to move on to X and Y. Handle jog the probe so that it is centered over X and Y on your part, and bring it down until it is about 1/8 of an inch above the top surface. Good, now press the edit button and find your way back to the menu where you've been choosing single surface probing, and check out this one, rectangle block probing. Hit the right arrow to go in and look at its parameters. There are some new concepts here, so let's just watch this probe cycle happen once and then talk about the parameters. Here's an ideal run. When I hit cycle start, notice how the probe scoots to the left and then down, probes the left. Then comes back up and scoots all the way to the right, off the edge of the right, and then down to probe the right-hand side. Then it comes back to the center and comes forward off the front edge and down to probe the front face, up and then all the way to the back and off the back edge and down to probe the back face. This is what we're setting up with a rectangle block probing cycle. The first line is for your personal work coordinate system. Mine is 154.80. The next line is jogging to position. We've already done that. We're centered and we're 1/8 of an inch above. The next line says, would you like to probe on Z before proceeding? No. We've probed Z a very different way, so we do not want to. There should be an N on that line. And then X, Y, and Z. And here X and Y mean something very different than Z. X and Y determine the dimensions on X and the dimension on Y of your stock. This is how you tell the mill how far to scoot to either side from the center so as to get off the edges before coming down. And ours is 1 inch on X and 1 inch on Y. And when you enter the number 1, make sure to follow it with the decimal point. Otherwise, it'll be interpreted as 1/1000th of an inch. 1 dot. Z here is us telling the CNC mill to please descend this amount before coming in to probe the sides of our part. Remember how we parked the probe about 1/8 of an inch above the surface? Well, the CNC mill is now going to go out over the edge and down this amount, down 1/4 of an inch. But you know what? 1/4 of an inch is not the right amount. This is what 1/4 of an inch looked like. I go out and down, but look how I just barely come over the edge. I'm not striking the flat surface with the widest part of the ball. I'm just barely making contact with it. I feel like I should be coming further down. So then I tried -0.5, 1/2 an inch down, but that feels too low. I feel like I'm falling off the bottom, almost scooting under the overhang a little bit. That doesn't feel right either. 0.4 inches, -0.4 inches was the sweet spot for me. That felt just right. And it's for me because it's dependent upon where I parked the probe to begin with. So you might need to do a little bit of searching to find the correct Z value for yourself. When you do, please make sure that you're not accidentally sending the Z value negative several inches. Asking the mill to descend with the probe -5 inches is very different from -0.5 inches. And -5 inches could risk crashing the probe. At the end of this, the probe should look very centered on X and centered on Y above your part. But more importantly, on the controller screen, the X and Y coordinate for your personal work coordinate system should be showing this physical position as 0, 0. And your Z position should be showing you how good you were at guessing 1/8 of an inch. And it looks like I'm terrible. I parked the probe at 0.29 inches. That's probably why descending 1/4 of an inch wasn't enough. And if you're looking at that number going, that's not 0.29, that's 1.29, I would say you're correct. The 1 inch is our part itself. We're 1 inch up from the top of the parallels, and then we're another 0.29 inches above that in order to be above the top of our metal. The last thing you're going to want to do is use the handle jog wheel to walk slowly at first, and then more quickly to get the probe away from your work area. It's vulnerable if you leave it down there too long. Good. Next up, we're going to run program 1003, our operation 2, to finish off the outer geometry of this cube.